So let me first introduce the jury. I'm Sherry from National Central University, and
杜兆 from Tang University.
高贤忠 from National Taiwan Normal University.
傅祖仪 come from National Taiwan Normal University.
吕博翰师大附中。
okay. And for the reporter, please introduce your team.
Honorable judges, we're the opponents. Good afternoon, and this is Team Uli Kanhua representing Taipei Rigo Senior High School. I'm the team captain Li Weifan, and here I'm introducing my teammates Li Qingyu, Li Hui, Xu Kaiyi, and Liu Sen. Thank you.
Opponent.
Hello everyone, we are Team Meku representing Qingxin Academy, and I'm team captain. My name is Liu Zhenye, and these are my team members' names: Chen Youan, Chen Jingjia, Wu Youlun, Xu Youchen. Thank you.
The reviewer.
Hello everyone, this is the physics team from Qingzhou High School, and I'm the team captain Jason Lee, and this is Brian Lin, this is Carol Yu, and this is Amy Wang. Thank you.
Okay, so in this round, reporter has already choose their experiment. So that's start from the preparation of your reporter. Sorry. You should write down. Each thing should write down the name. Okay, reporter presents problem 16.
Honorable judges and worthy competitors. Hello, my name is Ryan and representing Team Uli Kanhua and Typt Wiggle Senior High School. Today I'm going to talk about problem number 15, pancake rotation. And here's our outline for the presentation today. First of all, about the problem statement, if we place a few balls in the round container and we move the container around a vertical axis, the balls in the container might move co-directionally or counter-directionally with the movement of the container. And our focus is to explain the phenomenon and investigate the relevant parameters and determine its boundary conditions. And here's our experiment setup. We place an orbital table on our desk and fix a container onto it and place a datum point in order to track the path of the marble beside the container. And then we place a camera above the whole system to record the movement of the marble. And here's a phenomenon. We can tell that as the number of the marble increase, according to observation, the movement goes from rotation to stalling to counter-rotation. And here's our observation. We assume that there's an inertia force which directed at the tangent direction every moment when the container was rotating. And we assume that there are two parts of the cluster that may affect this phenomenon. Is that the red part is the movable part and the blue part is the static part. And in the static parts, the inertia force might be dissipated, and the movable part, it will cause the marbles to move toward the tangent direction. And if at the static part the force wasn't dissipated, it will go rotation, and if it is dissipated, it will go counter-rotation. And here's our observation. The path is tracked by tracker, and it do really support the theory I've stated previously that when the cluster is rotating, the static part might move, but when it is counter-rotating, the static part will stay in the same position. And our theory, due to the fact that we can't really define which marble is static part or which marble is movable parts, we came up with a quantitative theory to predict the movement of the counter-rotation. And here's our, before I talk about our theory, here are some few points that I have to say to support my theory. And the first is that we've seen that in this plate, the period of the green dot, which is also the center of the plate, its rotation around the center of the container is equal to the period of the container rotation itself. And the second point is that, according to our observation, the arrangement of the marble didn't change a lot, while the marble or even the cluster is counter-rotating. And the third point is that the marbles in contact with the wall barely move while counter-rotating, which also shows in this plate rotation. And the fourth point is that the plate and the cluster will have the same motion when they are counter-rotating and the plate is rotating in the container. And that's why we believe that we could approximate the counter-rotating cluster as a plate. And here's our theoretical derivation. According to my previous presentation, I've stated that the period of the center goes around the center of the container is equal to the container rotation itself. And so hence, as the center of the plate, which is the green dot C in the picture, finish a rotation, the K, which is the outer side of the plate, and also the outer side of the cluster, in reality, its rotation angle, which is related to C, is above like this. And this is according to the coin rotation paradox. And with the rotation speed of the container, consider the K's angular velocity, which is related to C, is above like this. And then we could convert it to a form including three parameters that is much easier for us to measure in the experiment, which is the X, standing for the container rotating speed, and its unit is revolution per minute, and Y, standing for the error proportion, and its unit is percent, and Z, standing for K's angular velocity, which is related to C, and the unit is radian per second.
And as you can see, there are 3 parameters in our equation. So we conducted a couple of experiments to prove our theory. And the first experiment is we observing about the relationship between the number of the marbles, which have a positive correlation with the area proportion of the marble, and the average angular velocity of a single particle. Before I talk about the experiment 1, here are some few points that I have to mention. Is that according to my previous presentation, I said that the arrangement was almost constant while the cluster was moving, and so even in different position in the cluster, when the cluster is counter-rotating, they all have the same angular velocity. So our definition of average angular velocity is 2 pi divided by period of marble going around a container, and the unit is radian per second. And here's our experiment setup. We keep adding marbles into the container and measure the period of the marble going around the container, and then convert this to the average angular velocity, and then we fix the RPM of the container rotation. And here's our experiment results. We can see that as the number of the marbles increase, the movement of the cluster go from rotation to stalling to counter-rotation to stuck. And stalling will be the boundary condition we will talk about later. And we can also tell that even the number of the marble wasn't the same. When the RPM was constant and the cluster was going counter-rotation, its angular velocity will almost be the same. So hence, due to this fact, so we conducted another experiment is to observing how the rotating speed of the container impact the average angular velocity of the counter-rotation. And here's our experiment setup. We measure the period of the marble rotation and then convert it to average angular velocity. And we change the RPM of the container rotation and then observe how the angular velocity will change while the RPM of the container is changing. And we've seen that there's a boundary condition the area proportion should exceed to make the cluster go counter-rotating in the container. So we find out a area proportion which is about 94%, and it's also 67 marbles in our container, which can make the cluster go counter-rotating in every RPM. So this is the theoretical value. So we can see that from the theoretical value, we can see that there's a proportional relationship between the RPM of the container and the counter-rotation rotating speed. And according to this residual graph from statistics, the data point in this residual graph is randomly scattered. So this do really prove our theory. And this is the experiment 3 about the boundary condition. This is the experiment setup. We record the marble number it takes to make the cluster stall, and then convert it into the area proportion we have measured by the MJ, which include the margin between the marble previously. And we accelerate the container rotating speed. And here's our experiment result. We see that even in these two containers with a big gap of area between them, the area proportion to make them go stalling is almost the same. So this do really prove that our theory is that referring that the main parameters to determine whether it is counter-rotating, rotation, or stalling is not the number of the marble or the area covered by the marble's cross-sectional area. It is the area proportion of the marble. And here's the comparison between the theoretical line and the experimental value. And we can see that in our theory, if the plate or the cluster is counter-rotating, the z, which stands for the angular velocity, should be bigger than 0. And according to our experiment result we got from experiment 2, we've seen that the angular velocity of counter-rotating won't exceed 0.8 radian per second in a condition that the RPM of the container is lower than 230 revolution per minute. So we change the Z from 0 to 0.8 radian per second. And then we can tell that the area which has been passed by the theoretical value will be the range that the cluster in the container go counter-rotating. And here's the reporter teams. We believe that this deviation was caused by the friction between the bottom of the container and the model itself, because it will slow down the movement of the model. And we could probably ignore the friction between the model and the model, because if we view the whole cluster as a system, it will be the internal force that we can ignore. And here's the conclusion. As the number of the particle is increased, the movement change from rotation, stalling, counter-rotation, and finally stop. And another point is that there will be a proportional relationship between the average angular velocity of counter-rotation and the RPM of the container. And another point is that our boundary condition calculated by the equation we get from our theoretical derivation is verified. And here's the reference. Thank you.
So question from the opponent.
So, can I turn to page 6?
Yes.
I didn't quite understand how you define the static part in the.
I've said in my presentation.
Yes.
That
So I want to know more about how you decide that.
I decide,
or how you know it is static or not.
Okay, so according to my presentation, I've said that we couldn't really define which marble is static or which marble is movable because the system is too complicated.
Okay, then can you turn to your first experiment where you're talking about the graph? Look at the graph.
Yes.
The graph of this experiment one. Is there a way to determine it is stalling or it is stopping? Because the angular velocities, they are all zero.
Okay, so when the cluster or the marble is stalling in the container, it will move like just rolling in a circle, in a small circle in the container. And if it is stuck, it won't move because
And
it's stuck.
can you determine the period of stop?
The period of stuck.
Yes.
Period of stuck.
Because you discussed last page.
Yes. Last page.
Because it's when you're talking about the angular, it's okay. I'm talking about parameter 2. Can you look at parameter 2?
Parameter 2.
Yeah.
Experiment 2.
Can you explain why you choose counter rotation instead of the normal rotation?
Because in my opinion, that the rotation happened in the container when the container is rotating. It's too complicated because there are collision or even like friction between it. And the main focus on the topic is about counter rotation. So I gave out a quantitative theory about the counter rotation.
And that's it, my question.
Thank you.
Opponent takes the floor.
So hello, judges and fellow opponents. Today I'll be the opponent side of the question pancake rotation. So first, the problem statement, which is explained by the reporter, is right here. And the structure of solving the problem, from their observation, they observed the different phenomenon and tested the different parameters and how they differentiate the data analysis. And second, they have a theory. They talk about the inertia force and imagine the balls as plates and explain why can they be as plates. And data analysis, they talk about the number of marbles and the speed of the container. And in the conclusion, they follow as small numbers stall in between and the counter at large numbers. So the pros and cons of the reporter. The pros are from the theory, they have detailed explanation about the theory and have pretty well explained theoretical considerations. Second, on their experiments, they have stable experiment setup with sufficient experimental data and theoretical verification. And for the structure, they are very easy to visualize diagrams. And the cons of the reporter, we think that they can have more theoretical versus experimental verification because there are no deviations investigated by the reporter. And the experimental improvements, we think that adding more points for more exact characterization, and we think they can add more different parameters as I'm going to discuss in the future. And thirdly, I think like for example, the size of the balls and the container or the friction, coefficient of the friction of the plate can be examined as a parameter. So in the discussion later, I will want to talk about the size and the mass of the balls. And second, I will want to talk about the view perspective, like on which perspective we view the balls and how will it affect the motion we see. And thirdly, I will want to talk about the spin on different axes or the different ways we spin the ball, how will it affect the outcome. And lastly, I will want to talk about continuous and non-continuous, which I will explain in my discussion. So can I get to the next phase?
Discussion.
So can I ask that what kind of forces are talked about in this phenomenon?
I think it's probably the inertia force, which is caused by the friction between the container and the marble right here.
Then how do you think the friction affects the different states of the marbles?
How do I think that? I think their effects are the same, but their condition is different, so the phenomenon will be different.
So you mean that? Can you explain again, like how?
Okay, so in my presentation, I've said that when the number of the marble increase,
Yes.
the movement will change from rotation to stalling to counter-rotation, right? So the different condition is that the number of marble is different. So even if there is an inertia force always pointed directed at the tangent direction, the condition is different. So the outcome of the phenomenon will be different.
Okay. Then can I want to ask, continuing from my short question, because you're according to what you presented, you said that your average angular velocity is 2 pi, which is a circle, divided by the period it moves, right?
Yes.
It moves a circle. Then if the marble is stuck, how do you determine the period of the rotation?
Okay, so if the marble is stuck, I think that's probably a point that I have to improve, is that I have to clarify how do I determine and define the period of the stuck in marble, right?
And if you're gonna define what's the period of stuck, then how will you define it right now?
I think there won't be an exactly number for the period of the time because it's stuck, so we can't really measure what the period of the stuck marble is.
Then nextly, I want to ask that I'll ask something about the friction. So, and when you talk about the deviation between the theoretical value and the value you estimate within the value you talk about, this graph. You said that you guess the yellow part is because of friction.
Yes.
Then did you try using different friction between like different kind of plates to rotate to actually verify this assumption?
According to my theory, my theory is ignoring the friction between the bottom of the container and the marble itself, right?
Yes.
So my explanation for this is that it is caused by the friction. And okay, so in my opinion, if the friction is bigger, the deviation will be bigger too.
So do you think that the friction is important, like the friction between the bottom and the ball is important to be for the phenomenon to be observed?
Okay, so according to my experiment result, I think it's not really that important, but it is the friction that caused the marble to presenting this phenomenon. But it's not really that important that will impact the counter-rotation part.
Okay. And about the parameters, can I ask that, did you try using different sides of the ball, or did you have a theory about what if I have larger balls or have larger mass balls?
I said that I convert the number of the ball using MHJ to the area proportion, right?
Yes.
So in my opinion, if the ball is bigger,
Yes.
if the ball is smaller, the outcome of the experiment will be much more like careful, just
Careful.
because when we add the marble into the container, the margin between the marble, as the size of the marble increase, the margin between the marble will be bigger, and we can't really that control the area proportion that carefully when we put the large size of marble into the container.
Then do you think there is a boundary limit for the size of the marble to observe this phenomenon?
To observe, of course, there will be a limitation for the size, because if you put a size with a bigger radius into this container, it won't really perform this phenomenon.
Okay. And secondly, from the perspective of you, we want to ask that usually from all of your experimental videos, you always look from a top-down perspective. Then what if you look at the motion from like the center of the plate? Like you look at the balls on the outer circle from the inside.
What if I look at this? I think it won't really it won't really show anything about about our theory or something else. It's just circling around the container.
Then what do you think the motion of the balls would be, like of the marble would be?
So you mean that if I stand in the middle of the container, it just like I've just said is that according to my observation and my experiment results, if the cluster in the container is counter-rotating, the area proportion would be really high, like about 80% or 90%. So the area proportion is almost the area of the container itself, right?
Yes.
So if I stand in the middle of the container, I will look and I'll look this cluster moving around me, and I think it will just go around me and then keep stalling.
Then okay. Then I will ask my next question. So my next question is because you all spin the plate in a circular method.
Yes.
Then have you controlled the rotational axis, like how large the circle you spin in?
Oh, I couldn't control it because the order table has a limitation.
A limitation for that.
Yes.
So do you think that the change of the circular motion of the plate, will it affect your result?
I think, in my opinion, I think the main parameter impacting this phenomenon is not the size of the circle it goes. It's the angular velocity of the container rotation.
Yes. Okay. Then can you explain about like how some balls are static? Like why do you think there will be like statistical balls and balls that will actually move with the container?
Well, it's probably because according to my observation, I've seen that the balls didn't move while the counter-rotation happened.
So what do you think? What derives this motion? Like the ball staying in place or not moving that much?
Like I just said, the force causing on those marble was dissipated.
So can you explain it more clearly or detail?
So if I put a force on an object, it will
Yes.
move, right?
Yes.
If it exceeds the friction of the object and the ground.
Yes.
And so, in my opinion, the friction will cause on this marble, but the force will be dissipated, and also the energy. So the energy might be like transformed to this way. So the balls will go counter rotation.
So like if the balls are static, do you think the forces on the net force is actually cancelled?
Actually cancelled. It's not. It's dissipated, but not cancelled.
So you think that the ball stays static because of dissipation?
Yes.
Okay. Then do you because you talk about on the marble on the plate.
Yes.
Then can I ask like an extensional question? Is that what if you think there are multiple layers of marble? Like how would the bottom layer of marble affect the top marble movement?
I think it will cause the friction between the bottom of the marble will cause the first layer of the marble move, and the marble will then push the upper layer of the marble. So I think we can't really that precisely say what will happen because it's too complicated.
So you think the friction on the bottom layer of the marble will affect the motion of the topper marble?
No, I think the friction between the bottom and the bottom layer will push the second, like the upper layer of the marble.
Then do you have a prediction of what, like if it is counter rotating, then what will the top layer be rotating?
I didn't have a prediction
Okay.
because it's not in the
Okay.
topic. No.
Then, so you think that the bottom layer will push the top layer and causing it to move?
Yes.
So you think the bottom layer? So do you think the bottom layer's friction will cause any effect to the top layer?
It will cause it
It will
to
cause
move.
it to move. So do you think the bottom layer of the plate will also cause a move? A friction will also cause a different rotation to the top marble.
I think how the upper layer marble will move is there are
Do you think
many
it-
conditions
do you
that
think
will
it-
impact this. You know, like the number of the marble and how fast you rotate
So
your
you
container.
think it is? So you think the friction is not important to the rotation?
No.
Okay. So then my last question is I want to ask that if you were to assume you have particles very small, then like this is a liquid, then what do you think the rotation would be, or how will it fit with your theory?
Like if it is really small, I think we can't really think of it says particle, but it's it's a big gap from the particle and the liquid.
I think that
Because as you just said, there are many layers in the liquid, so I think it's too complicated to say whether the liquid will move like just observing the first layer of the marble will move.
But being like but like small particles, liquid is of course small particles together. Well, it'll be close to a liquid, maybe not liquid. Then can you estimate the motion at that time?
So you mean that there's
For
only
example,
one layer of
for example, one layer of sand. What would you think it will be?
I think it depends on what shape of the particle it is.
Okay, thank you.
Now, Paula, summarize the discussion.
So from our discussion, we can know that they did the parameters on the marble amount, and they have verified their theory about that. It's not about the round motion or anything. But from my question, and when I asked about the marble, will the bottom layer of marble affect the top layer? I think that they have somewhat not really know their theory yet, because if the bottom layer of marbles would affect, you said that friction will affect whether it will be counter or will it be rotational. So I think you should factor friction in instead of factoring it out, because in your deviation graph, I think you actually said that friction is part of whether it will counter or will it be the same rotational method. And I think they have a lack of variables, because, for example, the size of the balls or the or either of the size of the particles, and other kind of variables should be measured. So that's my
Okay.
conclusion.
Question of the reviewer.
So here's my first question for the opponent.
Yes.
You've mentioned friction of many times. So what do you think the friction plays a role in this phenomenon?
I think the friction between the ball and the friction of the plate to the ball are very important to split to determine whether this will be a counter or a normal rotation.
Like both the friction from the bottom or the friction from the walls?
I think they are
Both
all
of them.
yes.
Okay. So for the question for the reporter, did you consider all the three friction force into your theory model?
I didn't because I view the whole cluster as a system. So I think the friction between the marbles will be your internal force. So I can ignore it.
Okay. And also, what I've observed that is because you say there is a last state movable part. So why did you use a plate which is all not movable part?
Okay, so
Yes.
according to my observation, what I just said is that it's not really that unmovable. It will move a little bit in my presentation. So I think maybe approximated as a plate is not really that precise because there will be a deformation for this cluster. So I think the much more precise way to approximate it is approximate it as a round sponge.
So what do you think is the main difference between the plate and the cluster of balls?
The main difference is that the cluster of balls might have a deformation when it's moving.
So it causes what? Causes what when you observe?
I think it causes the angular velocity, some deviation on the angular velocity.
Okay. So also what will it happen when you only fills the container with half of the balls?
What do you mean?
You only put half of the balls on the container.
A half.
Half, yes.
Oh, I think it will rotate
Like this one.
like this one.
Okay. And in your plate model, did you observe the motion which is rotating with the same direction?
Like what?
Like the video you showed with the plate model, it is the counter rotation, yes?
Yes.
So did you observe the movement of the rotation with the same direction?
Yes. So I say it's the same motion as the counter-rotational cluster.
Okay, so opponent, what do you think they should improve this model to fit the real condition?
Well, I think that thinking it as a plate might be an oversimplification for this phenomenon.
So what should they do?
I think that they should do more investigation into what's the difference and what are the assumptions that I made.
Okay. Preparation of the reviewer.
which reason this is Jason Lee, the reviewer from the VCC in Xinjiang High School. And now I'm going to review problem number 15, pancake rotation. And here is the performance. This is some pros and cons for the reporter. So first, they've got a clear graph with enough data, and also they've got a good delivery. And also their experimentation could prove their theory, and also their experimental setup is really good, and it's stable enough to reproduce the experiment. But also there are some cons for them. First is there's no clear theoretical model like the flying force analysis, like the friction force from different parts of the place and between both. And that's because they assume it as a plate. And also there are lack of the parameters like the sizes of the balls and the place like what Owen mentioned, and also the friction coefficient like from the plate and the balls. And here is the summary of the report. First, they define the movable part and static part of the balls in the container, and they use the angular velocity from the cluster and from the plate to explain why the direction is opposite or the same. And also they see the balls as a plate. And for the experimental confirmation, they found out that when the numbers of the marbles getting bigger, the rotation mode will form the same direction to slow, to counter rotation, and stop finally. And also they investigate about the rotational velocity of the container, and also they found the boundary condition of the rotating speed of the container, but they think that there will be deviation affected by the friction. So here are some performance for the opponent. So first, they are good at summarizing the reporter, and they've got good delivery, and they're asking critical questions for them. But also they didn't organize the questions well, and they didn't provide his opinions much on most questions. So here's the discussion part. For first, opponents asked about the forces that cause the phenomenon, and the reporter state that it is because of the frictions and the inertial force. And for the opponent asked about the perspective for perspective, and the reporter think there's no need to do that, and where our reverse view is the same as reported. And for the layers that opponent asked, and the reporters think that there's friction between layers to let all the layers start to move. And our reverse view is that not only friction, but also there's no force because the ball structure. And also, from my questions for the friction in the movement, the opponent think that there's all the frictions inside of it will affect the phenomenon. But in our reverse view, we think that the most important part is the friction from the wall, because it provides a torque when the ball is spinning inside around. It will provide a torque which makes it like spinning counter rotation. And also we asked about why did they use a plate with unmovable parts, and we probably think that is a simplified model for them. But with both me and the opponent think that is too simplified to describe the motion. And here are some missing points for them. First is the first analysis, and also their plate model is just too simplified to demonstrate the phenomenon. Thank you.
Conclude remark of the reporter.
Okay, so honorable judges and worthy competitors. I'm the reporter, and I'm going to talk about the concluding remarks. First of all, I have to appreciate all of the efforts by the competitors. And here are some concluding remarks I have to say is that first, I think there's a incorrect interpretation of friction by the opponent. Is that I didn't factor out the friction, all of the friction in this phenomenon. And I do agree that friction caused a lot in this phenomenon, but the only friction I factor out is the friction between the marbles. And the second point is that I should have done some extra experiment to explain the phenomenon, like just like what the opponent have just said, put another layer on it and try to like analyze the movement of the marbles at the second layer. And third is that I think my presentation is lack of force analysis, so that would be a point that I have to improve in the future. And the fourth is that I should have clarified the equation by comparing it to the experiment result, but it seems that the opponent and the reviewer didn't focus on this point. And the fifth point is that I should have done more experiments to investigate more parameters, so my presentation will be much more completed. Thank you.
Question from the jury.
Very good performance. I just wonder, I suppose you have learned the so-called Newton's law. I just wonder, can anyone give you some explanation, maybe just quantitative effect, how to use the force to express this phenomenon?
May I go first?
Yeah, please.
Could the tutorial change to the video about this? Thank you. Like if we take a look at this, for this one, the balls that attach to the edge of the container will move faster than this one. So in our reverse view, it is because the friction difference between them. And what causes the friction difference is the centrifugal force that produces from the rotational container. And it is because the numbers of the balls got much centrifugal force from to the edge to the balls from the edge.
Can I use the backward Taiwan?
Please.
So from the opponent's point of view, we think that if we take a look at the plate, if we look at this part, which is the bottom part, if we have a ball right here, it will have a force from the wall, like the reviewer said. So when it is moving in this direction, it will have the wall will give it a kinetic friction, like from this side. And if we call this ball A, this is second ball B, then we will know that this first, that ball A and ball B, both if we include the friction. Sorry, because sorry, wrong side. Messed up. So okay, we talk about friction. Okay. And ball A and ball B have their own friction as well, because they have collision on each other. So if ball is trying to move in this way, ball B will give ball A a friction on the other side. So it is B to A. And ball A will give ball B another friction, which is B to D. And these should be equal according to Newton's third law. And if we keep on adding balls onto the top, we can see that if the friction, these two cancel out, then we can see that this will be in a motion which they will call static. And if the friction doesn't cancel it out, then the ball will start moving in a circular motion on the plate. So that's our explanation. Thank you.
So could I answer? I do agree with the opponent, but there are some points that I would like to adjust. Is that the opponents say that the friction will be like dissipated while the friction transform to the center of the cluster. So I think it will like transform into it, but the friction right there won't really be dissipated because there's still a friction on the bottom from the bottom of the container with the marble itself.
Any more questions?
question for you three guys. How to measure the friction force? The ball and the ball, or ball and the container? How to design the experiment to measure the friction force?
I think I have tried to do this experiment before because I think we should like just stick the marbles together and then have the 3 layer of it, and then put the middle, and then try to like take out the middle layer, and then we can know what the force is.
In our reverse view, because we cannot know exactly if it is rolling or sliding because there's too many balls each end. There are also many counterpoints between the balls and balls or balls and plates, so we cannot get it exact. Also, we might know the value of the coefficient of reflection from the balls and balls and balls with plates, but we cannot know what the exact value in this experiment.
From our proponent's view, we partially agree, and we want to extend further, because mostly if we want to calculate friction, for example, if we're talking about force friction, we will usually tie the object together and slide it down the slope, and maybe track the acceleration to see the friction. But because we're talking about the marbles and the plate, which I think the plate to the marble is kind of, which can be done in the same matter. But if we're talking about the ball and the ball, or ball and the ball, because of unable ability to to actually track the acceleration of the balls when it's traveling, it's harder. Plus a lot of forces included. I think it's hard to calculate the coefficient of the friction, which makes it harder for us to determine the friction between them. Yes, that's my answer.
Okay. Thanks for the presenter. So it's already time for. So for the reporter, 6, 6, 5, 8, 7. Then the score for the opponent. 7, 8, 5, 7, 6. So the score for the reviewer. 8, 9, 5, 8, 7. present your report.
Hello everyone, I'm from Team Meku Meku, and today I'm going to report the problem number 4, color line. And this is the problem statement. When a compact disc or DVD is illuminated with light coming from a filament lamp in such a way that only rays with large angles of incidence are selected, a clear green line can be observed. The color varies upon slightly changing the angle of the disc. Explain and investigate this phenomenon. And our main focus of this problem is there is an angle where we can see a specific color on a DVD or CD. And this is our outline. This is our observation. At first, we use flashlight from smartphones instead of filament lamps to create a continuous spectrum of visible light. And we found out that the green line will only be visible when the angle of incidence is large enough. And next, we found out that when the angle of incidence is larger, the color of the line will be closer to blue. And when the angle of incidence is smaller, the color of the line will be closer to red. And next is our theory. There are spacing on the discs on CDs and DVDs, and it creates diffractions. And diffraction grating separates the polychromatic light into particular wavelengths. And like this. And in large angles, the blue and red light will diverge, which leaves the green lights, while in small angles, blue lights will appear. And if a polychromatic light hits the disc at an angle, we can firstly see the light as a parallel light, like this. And from there, we can determine whether the light waves would have constructive or destructive interference due to the difference in wave path difference. So we can get this formula in the picture, which is d cosine theta equals n lambda, and n is an integrate. And this is our experimental setup. We have a track that can put the disc on the track on it, and for it to change the distance. And we have the light source, which is the flashlight. And these are our variables. Our control variables are the spacings of CD and DVD discs. And our independent variables are the incidence angle and the CD and DVD spacing length. And our dependent variables are the color of the lines on the disc. And now I'm going to explain how we determine the tangent theta. This is the light source, and when the light hits the disc, it will create an incident angle. And this is the distance between the disc and light. And we determine the tangent theta, and the height of the light is 9 centimeters. And so we determine the tangent theta is the distance between the disc and light divided by 9. And these are our data analysis for the CD disc. For red and green, and for red, green, blue, and purple, the distance between the disc and the light is 15 centimeters and 22 centimeters and 34 and 44. And we calculated the angle is 59.1 degrees and 68, 75, and 78. And these are the pictures. And this is the data analysis for DVD disc. The distance between the disc and the light is 15, 20, and 33. And for the purple lines, we couldn't observe. As for the angles for these colors are 59, 65, and 74. And these are our observed pictures. As for the discussion, from the data chart we can see that no matter what kind of disc we use, the sequence of the color that we see is always red, green, and blue. And when the distance to a light source is longer, the color of the line will be closer to blue, which means a shorter wavelength. And when the distance to a light source is shorter, the color of the line will be closer to red, which means a longer wavelength. As for our conclusion, the difference of the disk doesn't affect the sequence of the color. And when the distance between the disk and the line is larger, the color of the line will be closer to shorter wavelengths, which means it is closer to blue. And when the wavelength of the line is shorter, the incident angle is bigger. The larger it is the spacing, the longer distance we need to get the same color line. Thank you.
Okay. So, some questions from the opponent.
So would you please turn to page 11? Like, what is the, like, there are other like forms. Like, what is the main value of this?
I think it is because the angle that we take the photo.
Okay, so could you turn to the page that shows the whole statement? So you say that a clear green light can be observed. So what? So did you observe the clear green light?
Yes, we did.
Like okay. So also, could you turn to page 10? Or that's fine. So did you calculate the frequency of the light wave from your theory?
No, it's from the internet.
Like what I mean is like did you got your values in the theory and get a theoretical value of your, like what colors should you get when you do this condition? Like did you get the value of them and fit it into your formula and get your theoretical value?
Oh yes, we did.
So did you compare it with your experimental value?
Yes,
Like
we did.
where did you show me?
But for this, like we calculated, but we didn't show it. Like for these four colors, the calculated degrees are 60, 67, 74, and 76.
Okay.
This 60, 67, 74, and 76.
Oh, okay. Thank you.
Okay, preparation of the opponent. is actual flow.
Okay, honorable juries and fellow competitors, this is Jason Lee, the opponent from the physics team student high school. And now we're going to host problem number 4, color line. So here's the problem statement. When we provide a light, when a compact disc or DVD is illuminated with light coming from the fireman lamp in such a way that omni rays with large angles of incidence are selected, a clear green line can be observed. The color varies upon slightly changing the angle of the disc, and explain and investigate this phenomenon. And for their main focus, they are trying to find out the relationship between the angle and the color. So here's the reported structure. So they first started with their observation, and they showed us when they change the angle, the color of the line moves from red to become green and blue. And also for the theoretical model, they described that the tiles on the disc, like CD or DVD, will form a diffraction of the light. And also they use a track to form their setup to control their distance. And also they use a foam flashlight as their light source. And for their experimentation, they changed the parameters like CD and DVD, and also the incident angle. And for their conclusion, they found out that longer distance from the light source and the disc will let the light become blue, and for the shorter distance, it will become red. So here are some strong and weak points for the reporter. So first, they got a clear delivery and also showed a clear photo on the colors, and also they have point setup for controlling the distance between the light source and the disc. And also they've got some weak points for the first. They didn't show the comparison between the theoretical value and the experimental value on the slide. And when previous I was asking, they really got the value. And also they could have reduced the other light source from the environment, like from their pictures, the background light is not totally removed. And here we would like to invite the reporter to come to the discussion part. So first, could you turn to the page that shows the problem statement? The problem statement, like first, it says that the problem statement says that you should use a light coming from the filament. So what do you think is the main difference between the foam flashlight and the filament lamp?
Okay, say that again.
The first statement says that you should use a filament lamp.
Oh.
So do you think that if you're using a foam flashlight, will there be difference?
We did use a filament lamp at first, but we didn't put it on the slide.
Why? Because it is what our statement said. So you should put it on. And also,
we think that it doesn't have a big difference between these two light sources because it all produces a continuous spectrum of white light.
Okay. So secondly, could you turn to page 11? Like you mentioned that the minor lights from on the side of the green light. What do you think is the reflection? I mean, you say is the angle of shooting. So did you remove the background light?
Yes, we did.
Like so you did an experiment.
We did the experiment in the dark room.
Okay. And also in our opponent's view, it might be caused because it is not a parallel light, because it is a foam flashlight. Maybe there's other angles of the lights because it is it doesn't just go right straight. It also goes to the side of the disc. And in our previous view, you could try to use something to wrap it up and only let the line that goes straight. So what do you think about that?
Okay, we will approach this next time.
So the next one, what is the main difference between a DVD and CD? Like the results from the result, what can you tell from DVD and CD?
For the result, if you look at this, like the larger it says that the larger the spacing, the longer the distance. You need to see the same color, and like the larger the spacing is referring to the CD disc.
Okay. So which one spacing is bigger?
CD.
Okay. So.
Oh, we can see it here at first. I don't know if.
So you mean like the tiles on the CD is the main reason that causes the different lines?
Yes.
Okay. Did you only get the variance of DVD and CD and the angle?
Yes.
Like, did you shoot did you picture the CD and DVD from the, like where did you picture it? Like if the, oh sorry, yeah, you see, like what?
Oh.
Yeah. So if the light source is here, and this is the iPad, and this is the display, so this is the light source. So where did you put your camera? Here.
Parallel to the light.
Like here. So within affected by the original line. Like, or where should it put it? Like the origin.
Like you put it here.
So this is your experimental setup, and this is the 9 centimeters. So this is the camera.
Like you put it here.
Right both the light source, or just like right there. So what do you think will happen if we shoot the face from here or other places?
I think it might affect the what we picture.
So what do you think? How will we like?
So we think that it might be a bit clearer.
So you mean like the side lights will become weaker?
Oh,
Like that you see here will disappear.
maybe.
So
It might be.
in honest view, because the tile is like this and small, so it will affect the angle of the angle of the lines. So it will become like from the picture there, it will affect the color of the main light.
Oh.
So what is like do you think that how could you improve the phenomenon that produced the side light? Like there are minor lights beside the main light. So how would you improve it if you're doing this experiment again?
think that we should put it here because like if we put it like here, we can restrict other light from coming from interfering the result.
Okay, that would be great.
Thank you.
That's fine. And also, okay, that would be the end of my discussion.
Thank you.
So from the above discussion, we talked about some problems with his setup, like the light source and the position of the light source and the camera, and also the current statement taught us to use a fireman language. They use a cell phone flashlight. So this might be something they need to improve. And also, in our opponent's group, we think that they should put their theoretical value on their slides, and in order to compare that if there is any deviation from these two, and to find out what is the factor. Thank you.
Okay. Question from the reviewer.
So, honorable judges and fellow participants, this is the Community Team Uli Kanha, and now I have some questions for both the supporter and the opponent. So, first question for both, where is the angle of incidence?
We think that the incident angle is here.
So, where is the point source and where is the disk where the
This is the disk and this is the light.
Okay, and
Right,
how about
the vertical axis of the disk and the light source to the center of the disk, and the angle between these two is the angle.
Okay. So next is, as the problem statement mentioned that there's a clear green light which means that there should only be green light. So first for a reporter, is there any condition where you only see green light the entire green light?
When the incident angle is small.
But you can see here that other than green light, you also have magenta or purple. How would you explain that? So then for opponent, where do you think you can see a clear green light?
Like if we use a parallel light source.
Okay. Then I would see. Then for the angle of incidence, where do you think the range of angle of incidence should be? Because the problem statement mentioned that it should only consider rays coming from large angle of incidence. So, and it says you should only change it slightly.
Yes.
So what is the range of the angle of incidence that you think the reporter or
I cannot calculate the theoretical right here, but from their experiments, I can tell that, and because when they change the angle, it will become blue, and from blue become green to red. So you could find the other condition of green and blue or green and red.
So in my opinion, when I use the formula. So why we can see green light is actually this. So here's the this. And for example, if here's a peak. And for example, the lamp is right here. So this is the source, which is the lamp. So these two large angles of incidence, for example, there's the pits of this. So we know that both
Stop here.
okay.
Preparation of the reviewer. Reviewer takes the floor.
So honorable judges and fellow competitors, this is the reviewer from Team Kanban, and now I will start reviewing problem statement number 4. So starting with this is a problem statement, and the reporter focus will be on investigating the specific angle. And so for reporter, it says that green light is visibly only when the incidence angle is large enough and larger than the angle closer to the blue. And for theory, it mentions diffraction grading and particular angle and wave path differences. And for experiment, it uses incidence angle, CD, and DVDs. So for the pros and cons for reporter, for pros, it mentioned diffraction grading, which is the most important concept for this problem. And he also did meticulous experiment usage of tracks to fix the CD for precision. And he has pair photos, and he also organized the results into graphs. And for the cons, there's lack of elaboration on the theory and did not bring out a comparison between theoretical value and the experiment results. And one of the most important things is that it doesn't fit what the problem statement wants, which is a clear green light, as I will elaborate a little bit more later. And next, for opponent, it gives sufficient own opinion on this topic, and he also points out the missing point, and that's not considered by the reporter. And for the cons, there's inefficient time management, and it also overconcentrates on trivial or unrelated issues, and some illegitimate questions asked. So for discussion, when the opponent asks, are there other lights visible in the picture, the reporter means that they are at different angle, and reviewer believes that angles is a really important factor in this problem. And for the potential theoretical derivation of the wavelength comparison with the experiment results, the reporter said it didn't calculate, and we believe that the reporter should calculate it. But here's, And for the difference between using filament and flashlight, reporter said all produce a continuous spectrum for light, and as the problem statement says that we should use filament lamp, we should follow the problem statement. And for the difference between CD and DVD, the reporter mentioned grading distance, and yes, we believe that it's an important factor due to the track distance differences between CD and DVD. And for reviewer's question, so what we asked about where will the observer see green light? Opponent said it's when it's parallel to the light source, and I do not, and the reporter doesn't really elaborate on it. And for where should the range of angle be, opponent said boundary condition is determined by experimental results. And so for pointments, it did not define the color green, and since it used naked eye, then we think that it should use more wavelength analysis. And before ending, I would like to demonstrate where we believe a pair of green light should be seen. So as we see from this problem, a pair of green light should be seen when the angle with S, E, and O, which is observer, is on the same plane, which means that the incidence angle is near 90 degrees. We will see a clear green line because when both here, when we define this as alpha, when the length Q is really, really long and alpha is really small, this line nearly equals to this line. And with a specific calculation, we can see that when this means that the entire wavelength, the wavelength seen on this entire line is the same, and that's why we can see a green line. And so we think that opponent and reviewer missed some point in discussing why we place the green line, which missed what the problem statement wants us to discuss about. And this is the end of the review in section. Thank you.
Reporter, please make a conclusion.
This is our concluding remarks. First of all, we discuss what kind of incident angle will result in the green light to be observed. And second, we use calculation to see the specific angle we need to see a specific color line. And thirdly, in the future, we will improve our experiment setup, including how we set up the camera and our experiment environment. And we will also improve our data, including comparing our theoretical data and our experiment data. Thank you.
Okay, so time for our question from the jury. Well,
the quick sheet, they highlight the light coming from a filament lamp. How do you think for all? How special is filament lamp? What difference from others lamp, such as phone flashlight?
So first, it's a point light source which includes a wide light range. So that means that all lights the light will come from all directions, so you can see. So it will be limited in the range. Since we live in
We'll agree with the reviewer because it will provide a larger range for the on the light spectrum. So it will include much larger range of the frequency, and it will on the other condition of that we could investigate how the wavelength will affect the light we've observed.
We agree with the reviewer, but we think that using a flashlight doesn't have a difference with the filament lamp because it also creates a light from all directions.
One question?
Okay, instead of change the height or distance for the lamp, what if I rock the disc? Can you get a sense for phenomena? Why? Understand my question?
Yeah. In our opponent's view, because they will also change the measurement angle, but it will only also change the observing angle. So it will definitely see different lights, but it will become harder to control because it changes to at both.
Does it mean changing the angle of the disc? So
Yeah, instead of changing the height of the lamp, changing the distance.
yes, the reviewer believes that it will have a significant effect on the color seen due to the angle tilt. The distance that the light will have to travel will vary, and thus the wavelength we see will differ.
We think that rotating the disc will have an effect to the experiment, and with a smaller incident angle, the color will still be closer to blue.
Okay, thank you.
Question? Okay, then now it's the scoring time. For the score for the reporters, 56346. The score for the opponent, 68667. The score for the reviewer, 67777. Okay, thanks to everyone.
high school. And now I'm going to report the problem 6, magnetic mechanical oscillator. So here's the problem statement. Secure the lower ends of 2 identical leaf springs to a non-magnetic base and attach magnets to the upper ends such that they repel and are free to move. So investigate how the movement of the springs depends on relevant parameters. And here's our main focus. We need to find out the relationship between parameters and the oscillations, and find out the relationship between energy decay and relevant parameters. And here's my outline. And then we'll talk about the observation. So here's my observation video. So when the first spring starts to oscillate, and then the other spring oscillates by a small amplitude, then we have three available variables. So first is the length of the leaf springs, and second is the volume of the magnets. Third is the distance between 2 magnets. And here is our observation about the couple oscillation. So we take 1 magnet and 5 centimeter distance between 2 magnets and 4 centimeters depth in a wooden base, for example. So the couple motion is the energy transfer from one mass to another. And then let's see the decay graph. So this print shows the peak of the amplitude decay and the total mechanical energy will also decay. So here's our definition about the initial release. So the deformation is about 2 centimeters, and our Young's modulus of elasticity of the ruler is 2.8, so that we can also view it as view our ruler as general leaf spring. And here comes the theory. So first, I want to talk the Young's modulus of elasticity. So we apply a force on the solid material, and it will undergo an elastic deformation. Then the deformation is reversible. So this formula shows that the applied force and the delta normal strain will relative to the spring length. This formula is the magnetic repulsion between 2 magnets, and we can see that the distance between 2 magnets is x, and the thickness of the magnet is T. Then here's the magnetic repulsion. So we can see that the radius of the magnet and the distance between 2 magnets will affect the magnetic repulsion. So and here's the force analysis of the couple oscillation. So you can see that this deformation is delta 1, and this deformation is delta 2. So you can see the total force is applied for Hooke's law, and the force of the magnet, and the drag force, and the force of the magnet is the couple term. So here's the derivation of the equation of motion. So we can see this formula is the magnetic repulsion derivation, and that we just mentioned before. Then also this formula is the derivation of resistance. So here is the equation of motion of the left spring's formula, and here is the equation of motion of the right spring. So and also I want to say that the force of the magnet is couple term. And here's our experimentation. So this is our experimentation setup. We have magnets, leaf springs, and wooden base. And we parallel to the ground, so that we need to, we don't need to consider the gravity. And we also have spring. So here's our data capture of the experimentation. So first we shot the video. Second, we import into checker. Third, we analysis of the x-axis position. And fourth, we get data from both springs. So the first experimentation, we change the length of the leaf springs, and we need to control the initial deformation, the type of the springs, the distance between two leaf springs, and the volume of the magnet. So it will affect the amplitude of the spring. So we comparison between various lengths of the springs. That this picture shows that if the length is smaller, the amplitude will become bigger, and we can know by this formula. And here's the peak of the amplitude. If the peak of amplitude, the amplitude peak comparison between various spring lengths, and we can get e-folding time from the fitting line. So this is a picture that's about e-folding time to the length of springs. So first, I want to talk that what is e-folding time. So we can see that it is. We can see if this is. See the e-folding time is b of exponential term. So we can know that if the e-folding time is bigger, then the decay rate will also bigger. So we comparison between various lengths of the leaf springs. Then the spring length smaller and the e-folding time is bigger. So in the second experimentation, we compared the distance between two springs. So we need to also control the initial deformation, the type of the springs, the length of the leaf springs, and the volume of the magnets. So it will affect the amplitude of the spring. So we comparison between different distance between springs, that we can get the picture like this. So we can get this. We can know that by this formula. So and here's the peak of amplitude. So if the amplitude peak, the amplitude peak comparison between various distance. So we can get e-folding time from the. We also can get the e-folding time from the fitting line. That just show like this. So we comparison between various lengths of the leaf springs. That the distance between the magnets, if the distance between the magnets is bigger, then the e-folding time will also become bigger. So here's come to the other experimentation, and we change the volume of the magnet. So we also need to control the initial deformation, type of the springs, and the distance between two leaf springs. Then is the length of the leaf springs. So it will affect the amplitude of the spring. So here we comparison between various amounts of the magnets. Like we use 1 magnet, 2 magnet, 3 magnet, 4 magnet, and 5 magnet to compare them. And we can know that by this formula. So here's the amplitude peak comparison between various volume of magnets. And so also that we can get e-folding time from the fitting line. And here's we compare between various amounts of magnets. That if the volume is bigger, then the e-folding time will also bigger. And here's my conclusion. So first that the derived formulas can be applied. then the distance between two springs becomes bigger, then the e-folding time also bigger. And third, the volume of the magnet becomes bigger, then the e-folding time also bigger. So unless if the length of string becomes smaller, then the e-folding time will become bigger. So that's all. Thanks for listening.
Question from the opponents.
Okay, so this is the opponent from the opponent team speaking, and the opponent appreciate the reporter's effort. And here are some of the questions that the opponent team wants to ask the reporter team. So can I take a look at the derivation of the force, magnetic force? Okay, so here can you first can you elaborate on what is the meaning of magnetization?
You mean
The M and the shown above.
you mean what is the magnetized?
Yes.
Is it
Okay, so let's move on to the next question. So did you derive this equation yourself, or just refer to a paper?
we have referred that.
Okay, thank you. So do you acknowledge that this equation only stands when the thickness of the magnet is way smaller than the distance between the magnets, so that the thickness can be ignored throughout the calculations?
Yes, the thickness will.
So do you think that in your experiment the thickness is way smaller than the distance between the magnets, and that it can be ignored? Because we don't believe so.
So you mean that if the thickness of the magnets will affect the result?
Yes, we believe so.
But we can know that by formula like.
Okay, I believe we'll have the discussion later. Thank you.
Okay then.
Evaluation of the opponents.
honorable judges, worthy opponents, this is Liu Fan from opponent team representing team Wu Yikanhua, and today I'll be opposing problem number 6, magnetic mechanical oscillator. So for this problem, I will not be restating the problem statement again, and the reporter's focus is on the oscillation decay and the energy decay, which is two of the most important topics I would like to have further discussion with the reporter later on. So for the summary of the report, the reporter had observed a phenomenon where they observed a couple oscillations and amplitude total and mechanical energy decay, and the theory they provided is the Young's modulus of elasticity and the repulsion between two magnets, and the EOM that is used to analyze the resistance. And the experiment, the factors that the reporters worked on was the length, volume of the magnet, and the distance between the magnet. And so here I would like to bring up some pros and cons we believe from our opponent, from our team. And we believe that the pros of the reporter is that they provided clear labels of the components of the experiment, and they provided the detailed steps of the experiment, and they conducted different experiments to test different parameters, and there was some qualitative explanation of the experimental results. However, we believe that the reporter should include error bar on their graph, and the graph that was shown on the slides was unclear. The labeling was unclear and lack of explanation regarding the graph. And we believe that the reporter should elaborate more on the equations that was shown on the slide. So now I would like to invite the reporter to have further discussion on the experiments. So continuing from the discussion previously, so did you guys create a model to estimate the period and then compare it with the experimental results? Okay, so for here you have derived the equation of motion for both of the leaf springs. However, did you create a model to estimate the period and then compare it to the experimental results?
We didn't.
Okay, thank you. So for this equation of force, did you guys take the direction of a force into consideration? Because our team believed that the direction of force will change throughout the oscillation.
We also didn't do this research too, but I think it don't affect much because the direction is just.
So the condition you're talking about is under the small angle oscillation. However, the opponent would like to doubt if this model stands when it's a large angle oscillation, since the problem statement doesn't state whether it's a small angle oscillation or a large angle oscillation. So you guys didn't take the direction of force into consideration. Am I correct?
Yeah, we didn't.
So here I would like to provide a model that we use, and we believe that it is very feasible to analyze the movement. So Juris, can I use the blackboard? Okay, thank you. So the concept that we utilized was to analyze the magnetic dipole moment of both the magnets, since here is a brief illustration of the whole experiment, and we can set this the magnetic dipole moment of this is equal to m1 and m2. And the force can then be elaborated through the interaction between the two magnetic dipole moments. And in our experiment, we suppose that the second magnetic dipole moment establishes a magnetic field around it to interact with the first magnetic dipole moment. So here's the equation that we have used. So according to the classical model of magnetism, the force can be elaborated as the gradient of magnetic dipole, the product of magnetic dipole moment and the magnetic field. And then the magnetic field can established by a magnetic dipole moment can be derived through the through an analogy to the electric dipole moment, which is 4 pi r cube and then so here we can use this motion to this equation above to further derive the force. So it may seem a little bit. So by using this equation of the force, our team believed that by using this equation of force, we can then analyze the motion that is inclusive of the direction of the magnet. So reporter, would you agree with me on this particular topic?
Would that fix the problem of the thickness?
I'm talking about can you show the video for during your experiment?
Okay.
So here it is clear that when it is deflected from its original spot, for example, when it's in this spot, the force experienced by both of the magnets does not equal to the equation of force that you have given on your side. So in order to include the directions of the magnetic force, we utilize this equation of force. So would you agree with me on that?
So yeah. I think you're.
Okay, thank you. So I'll just go back to this stage. So in your presentation, you have mentioned you have discussed about the decay of the total mechanical energy. However, did you consider the magnetic potential, take magnetic potential into consideration? Since our team believed that it is also an important factor in analyzing the experiment, analyzing the motion. Would you like me to elaborate on the definition of magnetic potential?
Yeah.
Also, basically, as you know, electric field, any electron will build an electric field around it, and so as the magnetic. However, so as the magnets. However, the analysis of the magnetic potential is quite difficult since it is elaborated by the curl of the strength of magnetic field equals to the curl of the magnetic dipole. So I suppose that you didn't consider the magnetic potential when you're considering the total energy. Am I correct?
Oh yeah. So we just consider the Hooke's law and the force.
Okay, thank you. So I have another question. So can you show me the page 24 about? I suppose there's a graph on it. So can you explain to me what the line on the graph means?
You mean this?
Yes.
Yeah. So if the length of the spring that the length of the spring is bigger, then it's evolving time to it's the evolving time will become bigger. So it means that the decay rate will.
Also, I mean by what are you trying to evaluate by with any factors of with that line? like linear regression, or is it just a trend line that you're just trying to like analyze the graph using linear regression?
Yeah, we just can like to comparison.
Okay.
Yeah.
Okay, thank you. So in your derivation of the resistance, the drag force caused by a resistance is the only damping that you have considered. Am I correct?
Yeah.
Okay, so our team believed that there is another like important factor during the during the analysis of the like resistance is the eddy current. So would you like me to elaborate on that? So eddy current is caused by established by the change in the magnetic flux according to the Lorentz law, and since the would you agree with me that the magnetic flux does change significantly throughout the oscillation?
I mean
The magnetic flux, since like the the magnetic flux, yes, changes significantly throughout the oscillation, since its direction changed, and the distance between the magnets also changed.
So there's no magnetic flux, so no coils in experiments.
Did you? But there is magnetic flux, magnets that you are using in your experiments, and magnets do establish establish magnetic flux. Would you agree with me on that? Okay. So in general, our team believes that eddy current should also be a factor that the reporter should have considered while deriving the resistance for the whole system. And in your equation of motion, you focused on the acceleration instead of angular acceleration. Am I correct? You analyze the system through by analyzing the acceleration and not rotation of the whole system.
Yeah.
Okay. Our team believes that is there any particular reason for you to analyze your system in such ways? Because we believe that you should take the torque of each force into consideration and then analyze the equation of motion and then elaborate the equation of motion by listing out the torques and the arms that the forces are active. Any further questions?
Opponent summarize the discussion.
Okay, so the opponent appreciates the discussion we had just previously with the reporter about their efforts on the experiment, and a few significant topics that we have discussed about is that first the reporter should have considered the change in the direction of the magnetic force throughout the oscillation, and second, the opponent should also include the damping caused by the establishment of the eddy current throughout the oscillation as one of the terms in the damping forms, and also. We would like to. We also pointed out some flaws in the reporter's theory, considering that they haven't taken the magnetic potential into consideration while calculating the whole mechanical energies, and that we believe that the opponent reporter should approach this by using
Question
the
from the
analysis
reviewer.
of the things.
Hello, fellow judges and fellow debaters. I will start to ask my questions. So, in your experiments, does the oscillation only happen on the whole spring or only in the upper part?
It's on the whole spring.
Okay, so in your setup, did you consider that the base or the brick will add another force when they are oscillating? Because when it flips over here, the brick may add another force. Did you consider the force?
No, because it doesn't have enough force to.
Okay, thank you. What do you think is the difference of the time consistent when the magnet is on the top or and on the bottom of the spring? Time consistent.
So it's just that we have the experiment that is the length of the spring. So if I put the magnet down the spring, so
Is the time consistent longer or shorter?
shorter.
Okay, thank you. Can you please predict what will happen if you change the placement of the magnet? Like, if you put it on the top or to the bottom, can you please predict what will happen?
Explain how.
So if you change the placement of the magnet, yeah, and you put it down, what was the difference of the phenomenon?
The encoding time will be here. So
Okay, Apollo, would you like to talk about what will happen?
Can you restate your question?
Okay, so can you please predict what will happen if you change the placement of the magnet on this string?
Change the magnet. Do you mean like the place where I put the magnet?
Yes.
So I mean the oscillation period will surely change, and in order to predict it, I suppose it will the period will be shorter since it is like it has a shorter distance from the base.
Okay, thank you. What do you think will happen if the frequency of the magnet burst is linear? Clear. So the normal magnet force would look something like this. And I asked what will happen if the magnetic force is linear. It means like that. What do you think will happen?
if we didn't consider
Normally the magnetic force is like this. Can you please predict what will happen if the magnetic force is like this? Okay, opponent, do you have any opinions?
I don't believe that is within the scope of the debate. However, it would like surely affect the period of the oscillation.
Evaluation of the reviewer.
I'm from Team Megu and today we're going to be reviewing the magnetic mechanical oscillator. So we believe that in this discussion there are four main focuses that should be discussed about. Firstly is to construct a reliable experimental setup with a reproducible results. Secondly is to talk about the periodic time of energy transfer. And thirdly is the displacement of two identical leaf springs. And last but not least is to investigate the effects of the important parameters and experimentally verify how they affect on the phenomenon. Okay, so next is about the merits and possible next steps of the reporter. So for the merits, for the theory, they had good theoretical considerations, and they talked about the magnetic repulsion, Young models of elasticity, and EOM resistance. But for possible next steps, because they have the lack of qualitative and quantitative explanation of the phenomenon, they use the incorrect use of formula, because on page 14 the formula is used only when the magnet can be seen as a very small magnet, but they didn't talk about which the size of talk about that we could see the magnet as to match the theory, so they used the wrong theory. And for their experiment, they verified many key parameters such as the length and the distance and the volume of the magnets. And they have sufficient experimental data and theoretical verification. But they could improve on having more analysis and theoretical matching. And for their structure, they had good diagrams and animations to let us have a great visualization. And for the opponent, they had clear thoughts and questions and summarized the reporter's presentation well, and extended the discussions on the parameters and identified merits and flaws of the presentation. But for the we would like to for the possible next steps, they could investigate more on the impacts of the magnetic force and the placement of the magnet and extensions of the spring. So now to the discussion analysis. So the opponent asked large angle should nearly be okay, next to the our presentation was cut off. So I'm going to move to the reviewer's questions. So I asked, what's the difference of the time consistent with the magnet is on top of the spring? And I asked my questions very quick, so there was no sufficient answer by both teams, but the reviewer's idea on this question is that we believe when the magnet is on top of the spring, the time consistent will be longer when it is at the bottom. And my next question was, what will happen if you change the placement of the magnet? And we believe that the upper the magnet is, the more the whole spring moves together, and the lower the magnet is, the spring will form a standing wave. And my next question is, what will happen to the frequency if the magnetic force is linear? And we believe that it will have the same effect as a curved magnetic force at a small distance. And lastly, I asked, I didn't ask this. Wait, thank you for listening to my presentation.
Reporter, please make okay.
Here's my conclusion mark. So in the theoretical, so we should take the thickness of the magnet into consideration to try to avoid the variation in the formula. And we could improve our theoretical model by using magnetic dipole moment. That would fix the problem of the changing angle during the motion. And we should take the magnetic potential energy into consideration. Then we could try to find out the effect of the eddy current in this phenomenon. Then we could try to investigate the angular oscillation instead the linear oscillation. In our experimental, we should improve our graphs such as adding the error bars into it and explain more about them. So and we could investigate more about the evolving time, if it's linear or exponential or other kinds. And thanks for the and suggestion from the opponent and reviewer. And thanks for listening.
Okay, any question from the jury?
Okay, I have a question for the opponent and reviewer, but I need transparencies from the reporter. Please go to page 15. Okay, basically, they assume that the drag force is proportional to the square of the velocity, right? Is that correct? Right. And then she discussed the so-called e-folding time, which assume that somehow the acceleration or the energy will decay exponentially. Do you think these two are consistent with each other, or they have some contradiction?
As I mentioned during the discussion, that they should like take the eddy current into consideration while considering.
No, that's not my question. My question is that these two points, are they consistent with each other, or are they actually contradict with each other?
You mean like
assuming that the drag force is proportional to the square of the velocity, and assuming that the energy dissipation actually cause the amplitude to have exponential decay.
Regarding this particular topic, I believe that if the drag force is really proportional to the velocity squared, the total mechanical energy should be decreasing linearly instead of exponentially.
Well, we're not sure of the answer, but we think that there is a contradiction between these two.
You're guessing because you don't know why.
Yeah.
Okay.
More question?
Can you go down the page 24? Yes, I hope you three guys can answer me the graph R squared. Do you believe the R squared is 0.99 for the review?
No, I do not believe that the R squared value is 0.99, and I was about to ask about it.
For review, there is your graph. Do you believe the R squared is 0.99?
We believe not, and we believe that it should be much lower.
Okay, and for the
Because we just have 4.2 to this graph. That's too less.
Okay, now and then it's scoring time. The score for the recorder. 55556. The score for opponent. 56688. report for the reviewer. Six, 5, 5, 6, 7. Okay, thanks to everyone.
I have a remark
Okay,
to
sorry.
make about the opponent. You could have done better, but you spent a lot of time trying to show us what the reporter doesn't understand. Instead, you should discuss what they have based on their experiment, discuss the content of their work instead of spending a lot of time telling us, you know this, you know that, but not discussing the experiment.
Yeah, add one sentence. It's about discussion, not tutorial. Okay, it's a tutorial. Okay. Any more comments?